Good morning, everyone. Morning, morning, morning. We'll give people a few minutes to get logged on and get tuned in, and then we'll get started into helping out with some homework. Oh, man. Okay, Sadie, what you got? Sadie's already in here with the questions. So Sadie, I was gonna send an email out about that, probably today or tomorrow. So the school board still needed to look at that. I think they looked at it last night, and so it just had to get approval from the school board, which it probably was going to. But yeah, so what I'm gonna do is they're moving an A down to like an 85% or something ridiculous. So what I'm gonna do is I'm gonna basically just get rid of all the extra credit I've been giving you guys. Yeah, Zach, it'll be just answering questions on the homework. So yeah. So, like I said, I'm going to just go back into the gradebook and take away all the extra credit, because if an 85% an A, 85% is an A, you don't need extra credit. And then do that, basically. Yep. So yeah, and there aren't going to be any like A minuses or B pluses or anything like that. They're just making it so it's either A, B, C or incomplete. Sorry, Kate. It doesn't really matter though. If like we're lowering, no, I'm not going to do anything, right? If they're going to make an 85% an A, then we're done. Then I'm just going to do like I'm going to make the assignments are what they are. So if you were getting an A, you'll probably still have an A, but your A will be a lower percentage. It'll be like an 87% instead of a 95. So, yeah. But an A is an A, so it doesn't matter. No one's going to go back and look at the percentages. All they care about are the grade on your transcript. What doesn't make sense, Cooper? So Izzy, I'll probably keep the test like curved, but I'll make it, instead of being out of 100, it'll be out of 120, which is what a perfect score was. So it'll be different. All of you will see your percentages drop in the next day or two as I update the grades. But most of you will probably see your letter grade improve, if that makes sense. So if you were getting an A or an A minus, you'll probably just have an A. If you're getting like a B plus, a B, or a B minus, you'll get a B. If the threshold is being lowered to 85, but people still got higher scores, it makes sense to remove the extra credit above 100%. Why are the grades being lowered otherwise? So Cooper, it's math, right? So let's say a perfect score on an assignment was 120. Right? If I do that 120 out of 100, which I usually do, that means that person will have 120%, which is way above an A. Okay? So instead of doing that, I'm now going to do 120 out of 120. So that person has 100%, which is still an A. Now, let's do the reverse scenario. Let's say someone before was only getting 100 out of 100. Then their grade would say 100%, and they'd have an A. But on the new system, it'd be 100 out of 120, which means their grade would drop to whatever that is. And 83%, which is a B. Now, I'm not going to do it exactly like this. but I'm going to switch it around a little bit. But this is the idea. So it's not me switching the grading scale, Valen. It's the principles. They're saying that the cutoffs now are an 85% is an A, 70% is a B, like a 55% is a C, and anything less than a 55% is an incomplete or something. No, what did they call it? They called it a. Maybe it is an incomplete. Let me look at my email real fast. There are no A minuses, Valen. There are no A minuses, Valen. Oops. Had the stream up, my bad. I think you guys did. Did you guys not get an email about it? I'm going to send something if I haven't sent something. Yeah, like I said, the school board was looking at it last night. Oh, no, it's not even ABC. They're calling this a pass. And it's anything greater than a 45%. And they're calling this an incomplete. So the reason why it's... Yeah, so I'm going to make it hard, so deal with it. So if A plus is real, will it raise our grade? No. A plus isn't real. That was just me showing it. No. Your GPA is still 4.0. What would your GPA if you get 4.0? It's not going to do anything to your GPA. I don't know about that, Weaver. I think for graduation it probably still does. That's a counselor question. I already explained it, Valen. Were you late? The idea is that I'm getting rid of all extra credit. And so there will be no more extra credit. So the assignments are going to be out of the total points, which means all of your grades are going to drop. And so this 85% of an A is going to be a little bit harder to get than it might seem. This is for all high school classes, Hannah, as far as I'm aware. So the thing is, if you were currently getting an A, you'll still have an A. If you were currently getting a B, you'll probably still have a B. If you were currently getting anything less than that, you'll probably be in this range. If you were currently failing, you'll still be failing. So if they want this to be the grading scale, then I can make my grades fit this grading scale. Yeah, pretty much. Yeah, my A was already close to an 85%, but because of all the extra credit, it's up to a 95%. If you want to look at like raw points. No, they're not going to change on the last day, Lauren. They should be, if they're not updated on Skyward yet, they should be soon. I'm going to work on that today and tomorrow to make sure my end is correct. Man, what teachers emailed you already? Freaking idiots! They weren't. We were supposed to wait until we got official word. Morons. I don't even know what she teaches. She's new, isn't she? Oh, she's the math teacher. Yep. So the grade scale hasn't changed in Skyward yet. I'll have to change it manually. So I'll do that today and tomorrow. Stop complaining about your math teacher. Yeah, so the Skyward hasn't changed it yet. It should be changing soon. And then I'll change everything as well. So yeah, your Skyward will get changed. I guess the email didn't say, like, to not tell people. Okay. Let's see. Yeah, so, well, the problem with Miss Moore is that this was her last year teaching, and so I sympathize with her and understand that there's no way that I would want to do this if this was my last year teaching. I'm fine with just shoving everything online and saying, figure it out yourself. So I kind of can sympathize with Moore in that regards. Yeah, Parker, there's only one on the assignment with no reaction. So let's get into the assignment. And stop talking about stupid bureaucracy and dumb stuff that other people are trying to tell me how to do my job. I know, I love more. No, Olivia, I was at the school for like 8 hours yesterday moving and packing up stuff because they apparently decided to spring us on us that we were supposed to do everything. So, yeah. Yeah, no, I'm a little upset about a lot of things that are going on right now, but we can definitely work on this assignment because I'm not upset about this assignment. All right, so I didn't get this assignment posted until last night, again, because I had to do a bunch of stuff. Thanks, Parker, I appreciate it. So if you go into the honors class and you go to the modules, right, we've got introduction, we've got the chapter 13. Okay, so we're on the chapter 10 part 3. So we have the predicting equations submission. I decided to break up the assignment into 2 separate assignments because doing it as one was just huge and I didn't want you to have to redo it multiple times. And so I broke it up into 2 halves. The first assignment covers problems 1 through 10, and the second assignment covers problem 11 through 20. The reason why the second assignment is 71 points and the first assignment is only 61 is because on problems 11 through 20, we had a lot more of the ones where you had to write the total and net ionic equations, and so those ones had more points to them. On both assignments, the last question is an upload, and it's worth 10 points. So scroll down. So right. So on the very last question, we have you have to upload a file, and so this will be 10 points here, and then it'll be 10 points tomorrow. Yeah, we moved it to Friday because I didn't get it up until last night. Yeah, but some of the questions are super easy, like what kind of reaction is it? Right? That shouldn't take you very long. Right? What is this one? This one's a double replacement. Okay. Yeah, one would have been massive. What the? Oh, oops! Shoot! I didn't mean to say deny on that. Sorry, I didn't mean to say add. Gosh, dang it! Sorry, Lauren. I did not mean to block that. I don't know why back page is a blocked term. Okay, so Zach wanted to do 4 and 9. So since we're on this, let's see. That's problem 7. Problem 5. Problem 4. Okay, we're going to allow back page. Apparently back page is some reference to something sexual. Okay, can we submit the front page first on the back? Yeah, that's fine, Lauren. That's totally fine. Even though the problem numbers don't line up, that's totally fine. Yeah, anyway. Oh, wait. Oh, was it single replacement? Did I just misclick? I didn't really read the problem. Oh, yeah, sorry. It's single replacement. I'm done. Thanks, Cooper. All right, problem number 4. Okay, so problem number 4 says, which kind of reaction is, man, this is small. I'm going to make it bigger. So what kind of reaction is problem number 4? Ki plus lead nitrate, and then it asks for that. So first thing we see, it is a double replacement, okay, because we have one compound reacting with another compound, okay. Oh, Olivia, have you not been tuning in live? Gotta tune in live. Okay, so double replacement here, and then we go to the reaction, right? And so apparently if we look at the reaction, I've got it set up to where one of the products is aqueous and one of the products is solid, right? So we need to figure out the formula of the aqueous product and the formula of the solid product. So the reason why it's double replacement, Hunter, is because Ki, potassium iodide, is a compound and lead nitrate is a compound. So we have 2 compounds. Well, Olivia, welcome to the stream. So when we mix 2 compounds together, we have AB plus CB, and so it's going to be a double replacement reaction. So let's go back to the notebook and let's actually work through this problem, how it would work out. So we'll get to that, Zach. I'll show you. Okay. So yeah, Ki are 2 individual elements, potassium iodide plus lead 2 nitrate makes, and then we have something that's aqueous and something that's solid. So let's think, as we switch these, right, as the lead and the potassium switch, okay, we're going to get lead with iodine and potassium with nitrate. Now, how do we know which one of those is going to be a solid? If you remember, a couple days ago, we did a stream with solubility rules. And from the solubility rules, we know that K is in here as a soluble one and nitrate is a soluble one. The big thing is this idea here of this lead, right? Don't forget, lead is insoluble solid with a lot of things. Okay. And so that means our lead compound is probably going to be the solid one. So I'm going to do the potassium one first. So potassium is going to combine with nitrate. Now, potassium being an alkali metal in the first column, right? Potassium right there. So potassium, right, forms a charge of +1. Nitrate is a polyatomic ion that we have memorized that has a charge of -1. So we have +1 and -1, so that formula works out. With the lead, in a double replacement reaction, the compounds keep their charge. And so over here, if this is the right formula for this lead nitrate, and there were 2 nitrates for every 1 lead, the lead had to be a +2. And so if we pair it with iodine, which is a -1, right, based on periodic table, right here, iodine, okay, it's a halogen, so it's going to be -1, so we have PbI2. So why did they keep their charge? Good question, Izzy. Because in a double replacement reaction, your ions are just switching partners. There's no electrons changing around, right? In order for something to change charges, there would have to be a transfer of electrons. And in a double replacement reaction, you don't get electrons transferring. You only get the ions swapping partners. Okay. All right. So Enya's saying it's going to be balanced as 2-1-2-1. Let's see, we've got 2 iodines, so we need 2 iodines. 1 lead, 2 potassiums, so we're going to need 2 potassiums there. And so yeah, our coefficients are 2, 1, 2, 1. Now this problem also asks to write the total and net ionic equations. So in order to do that, we have to ask, okay, does potassium iodide split? Yes, it's aqueous ionic, right? Aqueous ionic splits. So 2K plus 2I minus, right? Lead nitrate, same idea, aqueous ionic, so it's going to split Pb2 plus 2 nitrates. Potassium nitrate is going to split 2K plus 2 nitrates. Lead iodide stays together though because it's a solid and solids don't split. Okay. And so the potassiums are going to cancel and the nitrates are going to cancel. Those are our spectator ions. And so in the end we have 2I minus plus Pb2 plus makes PbI2 solid. And this was problem number 4. Okay, so again, the potassium iodide splits into the 2 goes through, so 2K plus, 2I minus. The lead nitrate splits, so Pb2 plus and 2 and a 3 minus. Potassium nitrate splits, 2K plus, 2 and a 3 minus. The lead iodide stays together because it's a solid. The potassiums are spectators and the nitrates are spectators. And so in the end, it's 2I minus plus lead makes lead iodide. Hey, BA Brand? Bait Brand? Thanks for following. Oh, mine shh. Thanks for the follow too. All right, so we go over to the homework assignment, right? We're doing our double replacement. Yeah, we'll do a couple more, Hannah. We've got another like half hour that we can still do more problems. I did want to show how to plug this into the canvas for anyone that was confused. Okay, so we look, right? We figured out our formula for potassium nitrate was KNO3, and we figured out that the lead compound was PbI2. The coefficients we said were, oh, I need to delete this random A thing, my bad. Were 2, 1, 2, 1. What happens? We said potassium iodide splits, potassium nitrate splits, or sorry, lead nitrate splits. The first product that was aqueous, that's our potassium nitrate, that stays together. Oh, sorry, that splits, I'm dumb. The solid one stays together, okay? Because we split, 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 and then we let the last one stay together. In terms of spectators, we said the potassiums were spectators and the nitrates were spectators. Right? So that's kind of how you do the problem. So you do all the work on paper. That way you can have a picture of it for your submission. And then going through the problems, you just kind of do these. Number 2, I believe, is a combustion. Yeah, the second reaction is combustion. So remember, combustion is when you take a hydrocarbon and react it with oxygen. The products are CO2 and water. Decomposition is when you have just one compound and it'll break apart. Decomposition has like heat or something else. I'm just confused how to balance number 5. So let's see. Let's go down. Number 5. That's this one, right? Parker, did you figure it out? Can something be a solid like frozen in ice? So the only things, something be aqueous but be, oh sorry, I misread the question first. No, it can't be aqueous and a solid. You could have a substance where like some of it is aqueous and some of it is solid. But for the most part, when we look at an equation, we're going to have something be solid on one, aqueous on one. Oh, number 7, the combustion one. Oh, like question 7 on the canvas? No. Like question 7 on the worksheet. This one, C4H10O2. We can do a combustion one. So it's combustion, right? So was this a double replacement reaction? Which one, Olivia? Oh, the one we just did. Yeah, the one we just did, number 4, was a double replacement. I think I already clicked that. Yeah. So what kind of problem is number 4? It's a double replacement because we're mixing 2 compounds. All right. Balancing for this guy. Okay. So remember C4H10 plus O2. Let's go back to the worksheet and do that. So this is problem number 7. C4H10 gas plus O2 gas. So our products are CO2 and H2O. Right, so always CO2 and H2O. Whenever you take some carbon, hydrogen, something, and add oxygen to it, it's always going to make CO2 and water. So you got it. This is a combustion. So combustion reactions will always follow this format. Something with carbon and hydrogen plus oxygen making CO2 and water. So with balancing, 4 carbons there, so we know we need 4 carbons there. 10 hydrogens there, so we know we need a 5 here. And then this is where things get a little tricky, is when we try to do the oxygens. So 4 times 2 is 8. 5 times 1 is 5. 8 plus 5 is 13. So this is where we have a problem. Currently, in this reaction, we have 13 oxygens on the right-hand side. But on the left, we have O2. There is no whole number that we can put in front of here to make it equal 13. But we can do a fraction. We can do a decimal. We could do 6.5, right? Because if we did 6.5, 6.5 times 2 gives us 13. Right? But we can't leave it as 6.5. Reminder, we have to take the whole equation and multiply it by 2. And so in the end, our equation is going to be 2 C4H10 gas plus 13 O2 gas makes 8 CO2 gas plus 10 H2O liquid. It doesn't matter, Tyler. It's whatever you're more comfortable with. Like, so if you like 6.5, if you like 6.5, if you like 13 halves, whatever you're more comfortable with mathematically, it works out to be the same. So they're all just different representations of the same idea. So, all right. So 2, 13, 8, 10. So let's go back to the canvas real quick, because this is all we had to do on this problem. So if we look on the canvas, okay, our products are CO2 and H2O. Yeah, Cooper, we can get to that one. So CO2 and H2O. And then notice I kind of gave you a hint here to tell you that this was a pretty complicated one to balance. I told you that it should be a 6-digit number, even though there's only 4 compounds. And that's because we get some big ones. So we said this was 2, 13, 8, 10. So that's our 6-digit number, 213810, because of the coefficients 2, 13, 8, 10. In the balancing, make sure that you have your equation in the same order up here, because when you're writing the equations, you probably could write them maybe backwards like this. So make sure that when you go to fill in this one, that your equation is in the same order as I have it in the previous question. So in all the questions that ask about balancing, make sure you look to the previous one to make sure that it's in the same order that I have it written. Otherwise, you'll have it balanced properly, but it'll count it wrong because you wrote it in the wrong order. So check, check. So let's go to the second assignment. Cooper asked a question about 17. So we'll do 17 and then potentially 12, Hunter, if Canvas will load. There we go. All right, so let's see. Problem 17. All right. So I should have put this somewhere in the instructions on the assignment. I'm going to write it on the notes here in a second. But so we have HBr plus Fe. So we've got a compound plus a single element. I'm going to get to as many as I can, Kate. The problem is heat in the beginning will be a product too. No. Heat is not. Heat is just there to tell you that heat. When you see heat in a problem, it's really just to say, hey, this is a decomposition. Grades on Canvas? No, my grades are fine. I don't know what are you implying, Tyler? Oh, you mean like me as like my personal grade on Canvas? With only like 5 problems done? Anyway, sorry. HBr plus Fe. So, oh, yeah. So this is the test student that I'm pretending to be. So HBr plus Fe, we have a compound plus a single element. So when we have a compound plus a single element, I got it, Xander. It just took me a second. We know that it's going to be a single replacement. Now, for single replacements, your brain should say, wait a minute. Single replacement, I need to check something. Single replacement, I need to check the constants and reactivity series. Okay, so we're going to come back to this here in a second. All right, so I'm going to pull this up to make sure I have it. So, all right, so let's write this equation. Okay, so let's close this. Let's go. All right, so this is number 17. So we have HBr aqueous plus Fe solid. Okay. So iron is a metal, right? So iron is going to be attempting to replace hydrogen. Okay. So iron is going to replace hydrogen. So can iron replace hydrogen? To answer that question, we have to go to the reactivity. Okay. So let's see. We got to find iron solid. So here's iron, right here. Where's hydrogen? Hydrogen's down here. So iron is higher up on the list than hydrogen is, and so iron is more reactive, and so iron will replace hydrogen. So this reaction will happen. Okay, so we go back to our thing. So after we double check to make sure that the reaction will happen, we know the iron is going to replace the bromine. The hydrogen. So we're going to get iron with bromine and hydrogen by itself. Now, this is very, very wrong. Okay, this is the thing that I need to tell you guys on the worksheet. Iron will form +2 in single replacement. So I should have mentioned this to you guys. Yeah, that's why I'm telling you right now, Anya. No, you're good. You're good. So yeah, I should have mentioned this at the start of the worksheet or something. The reason why I didn't mention this is because usually in class we've done a lab with iron, and we've already talked about how iron in the lab that we did formed a charge of +2. But because we aren't doing the lab this year, it never came up, or it hasn't come up yet. So that's why I've got to tell you it here. So iron will form a +2 in a single replacement. Is this in all single replacements? All single replacements that we're going to do, there are some other, it's hard to make a hard rule for something like iron because iron can form either a +2 or a +3 stably. So anyways, so because iron is going to be a +2 and the bromine is a -1, we're going to have two of these guys, FeBr2. Right? And there's something that says this shouldn't be aqueous. Going to be aqueous. The other thing we've got to remember about hydrogen, we've got to remember something special about hydrogen when hydrogen's by itself. Yeah, it's got to be H2. Right, so hydrogen gas. We have our diatomics, right? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And so hydrogen's going to be H2 when it's by itself. So if we look at this, look at the balancing, 2 bromines, 2 hydrogens. Let's do 2. I think we have to do a total and net ionic here. Yep. How do you decide what to replace? Well, iron's a metal, right? So it's going to replace hydrogen, which is acting like a metal. So remember, compounds are always metal, nonmetal, positive, negative. So are you talking about this idea, Tyler? Remember, it's Honeyfickelberg. H2O2, N2, I2, F2, Cl2, Br2. Okay. How do you know the hydrogen is a gas? So there's a couple ways to know hydrogen is a gas. One is the fact that if you look at the elements on the periodic table, the colors in red, nitrogen, oxygen, fluorine, all the noble gases, and hydrogen, they're red, which means they're gases, right? All the elements that are in black are going to be solids. The mercury and the bromine are our 2 liquids. How is the aqueous and gas on the other side? I know you've gone over it, but I'm confused. So I just explained gas. The aqueous is because we started out with HBr being aqueous. And so our FeBr2, because it's ionic and it's soluble according to our solubility rules, bromine is a soluble anion. And so because it has the bromine in it and because we're dealing with an aqueous solution already, it stays aqueous. Now, if you weren't 100% sure, you can always check on the Canvas assignment because I've got the phases plugged in for you. So if you look here on this one, you'll see the products are aqueous and gas. And so I've kind of helped you out a little bit by helping you with the phases. So we said it was FeBr2 and H2. Okay, a couple more questions. Wait, can single elements not be aqueous unless they are cation or anions? Yeah, you cannot have single elements don't dissolve. No, Billy June, but you go right ahead. Why isn't the H aqueous? So a hydrogen by itself, hydrogen gas, is more likely to be a gas. If you were to do this reaction in a lab, if you were to take solid iron and you were to pour hydrobromic acid on top of it, it would bubble violently, and that gas being produced is hydrogen gas. So hydrogen, to a very small extent, can dissolve, but it actually will turn into a gas in this state. And again, you guys would know this a little bit better if we had spent the time in class doing the lab, and so I apologize that you guys are missing on that experience. What do you want to do for questions where there's not reactive enough? So if you look on this one, if this reaction had been no reaction, you would just say there is no reaction for both of these. And if the reaction doesn't happen, you just say 0. Yeah, so, ha, I beat you to it, Cooper. All right, so we said this was FeBr2 and H2, and the coefficients were 2, 1. All right, let's see. Zach's question, I don't remember what Zach's question was. How do you decide what to replace? It has to do with the idea that iron is a metal. Compounds are always positive, negative, and so the iron is going to replace the hydrogen. In a compound sense, hydrogen is going to act as a metal with a positive charge. So that Tyler's just repeating Zach's question. Enya, so H doesn't have a charge even though it broke off with a compound is because no electrons are exchanged. No. It's because in this case, in a single replacement reaction, electrons are exchanged. So our iron goes from being neutral, right, from having no charge, to being in a compound with a charge of +2, which means the iron lost 2 electrons. Where do those electrons go? They go to the hydrogen, and so the hydrogen is gaining those electrons. And so in a single replacement reaction, there is a changing of electrons, which is why the hydrogen turns out to be a gas. Yeah, I hope that's not too confusing. Okay, we've got time for, I guess we should finish doing this one, right? Oh, actually, we should go back and finish doing it. All right. Okay, so Enya, the hydrogen in the compound in HBr, the hydrogen was a +1 already. And so because it was already +1, giving it an electron gives it a charge of 0. And so it changes it from being +1 back to 0, which is why it's in a compound. As H2, hydrogen gas, it doesn't have a charge. It has a charge of 0. So it was already positive, and so it goes down to 0 by gaining electrons. Hunter and Tyler both asked for question 12. So let's go up to 12. There were 2 hydrogen atoms. Right? So because the iron lost 2 electrons, each of the hydrogen gained 1 of those electrons. Yeah, good questions. All right, problem 12. Oh, okay. So this is a single element, a single compound, magnesium oxide, plus heat and electricity. So heat and electricity should go off in your brain and say, right, that's a decomposition reaction. The other way we know it's decomposition is because we have a single compound, and the only thing a single compound can do is break down, right? And so we've got decomposition, our single compound is going to break down. And so we apparently, if we look at what I've got here, it's going to break down into some sort of a solid and some sort of a gas. So let's see if we can figure it out. Let's go to our worksheet here. So this is question number 12. MgO has a liquid plus heat and electricity, which it's not really important to write that out, but I'm doing it to be thorough. Yeah. So on the actual worksheet itself, there's that space. You would just write decomposition there. Thanks, Sadie. All right. So is MgO one of the special decompositions that we learned about? Reminder, there are 3 special cases with decomposition. There's metal hydroxide, metal carbonate, and metal bicarbonate. Magnesium oxide is a metal oxide, and so it's not one of the special cases. And so we don't have to worry about the special things. This is not a special case. We're going to know it breaks down into individual elements. It's going to break down into magnesium and oxygen, right? If we remember from the canvas, right, magnesium, just a metal by itself, is probably going to be a solid. Oxygen, right, don't forget, we already wrote the diatomics. Oxygen should be O2, and that's going to be our gas. for balancing, yeah, Izzy's got it. For balancing, we've got 2 oxygens, so we know we need 2 and 2. So our coefficients are 2, 2, 1. And that's number 12. So technically, back on 17, I should have done total and net ionic. You would have split this would have stayed together, you would have split this would have stayed together, and the bromines end up being spectators. So just to kind of finish up 17. Oh, literally just did it. Yeah, I'll write it out. 2H plus 2Br minus plus Fe solid makes Fe2 plus 2Br minus plus H2. I'm skipping phases so I can have the space. The bromines cancel. Final result is 2H plus aqueous plus Fe solid makes Fe2 plus and H2 gas. Okay. So Izzy, no. The heat and electricity aren't technically, I mean, depending on what kind of state or how you approach the problem, but they're not chemicals, right? They're not reacting in the sense that we would think about a reaction. They're just there because they kind of tell you what is needed to get this reaction going. If you add magnesium oxide by itself, it's not going to break down to the magnesium oxygen. The only way to get magnesium and oxygen to break down is to have it split. So Tiara, 1 through 10 are on part 1, and 11 through 20 are on part 2. So both of these would be on part 2. 11, 12, and 13 weren't on the PDF? Yes, they were. Oh, they're on the first page of the PDF, Parker. They're on the bottom of the first page. Okay, finish 17. Answer that question. Sure, Tyler. We talked about heat and electricity. This is... I don't know what you want me to say it again, Trinity. Oh, why does it have to be both electricity and heat? Because magnesium oxide is actually a really stable compound. To get it to break down, you have to put in a lot of energy in order to get it to break apart. And so in this one, you have to do both heat and electricity. H2O doesn't split in number 5. Isn't that what number 5 is? Is water splitting? Aren't we just splitting water in number 5? Yeah, that's what 5 is. Water splits into H2 and O2. Yeah, that's that. Water. You can break down water with electricity. We have to predict what compounds need heat to split. No, Anya, you don't. Wait, why is it H2 and not 2H on the total ionic? So it's 2H here, and it's H2 here, okay? Because hydrogen as a gas doesn't split, it doesn't change. So it stays H2 as a gas on all 3. When hydrobromic acid splits apart, this is H+, and so the 2 goes through. When you split something, you don't do... When something is an ion, it doesn't follow this diatomic rule. This is only when something is totally by itself in the total equation. When you split a compound, so hydrogen here as an ion does not have to be a diatomic. It does not have to be H2. Water doesn't split, but you can break it down into hydrogen and oxygen gas. And not necessarily, Izzy. It just kind of depends on the situation. All right, so Olivia and Parker are both asking for number 9. Parker says number 9 is no reaction. Let's double check to make sure that that is the case. So problem number 9 says zinc plus magnesium sulfate. So the question is, can zinc replace magnesium? To answer that question, we need to look. So this is a single replacement, okay? For single replacements, we always have to make sure they happen. So let's go to our constants and reactivity series. Here's zinc, and here's magnesium. Zinc is less reactive than magnesium. So because zinc is less reactive than magnesium, we go up here, the zinc cannot replace the magnesium. And so this problem just got really easy. There's no reaction, 0. Technically we should say this stays together, but then we just say there is no reaction, Oh, this would split, my bad. And then there is no reaction. So question number 9 is the only one that doesn't react. All the other ones react. You should check anyway on the single replacements, but just as a heads up, I wanted to throw one in there that didn't react. So yeah, there is no reaction. You would just, so if you were like writing this on the actual paper, you would say like zinc plus MgSO4, no reaction, right? Now, if it did react, you would do like zinc plus magnesium sulfate, and you'd go from there, and you do some other stuff. But there's no reaction, so it doesn't matter. Technically, this stays together and this splits. But again, there's nothing here because there's no products, because there's no reaction. Okay, last time someone asked about problem number 10. Sure. So let's look at 10. All right, problem 10 says potassium iodide, Ki, plus bromine. Okay, so it's going to be a single replacement. Now, in this case, bromine, which is a non-metal, is going to be attempting to replace the iodine. Now, when we look at non-metals, we want to look at the left. So here, bromine is here, iodine is here, and we said that towards the bottom was more reactive. So bromine is more reactive than iodine, and so bromine will replace iodine, and so this reaction will happen. So let's write out the equation for this reaction. Ki plus Br2. So this is problem number 10. Potassium iodide, aqueous, plus bromine. Did I say it was aqueous? I did say it was aqueous. Probably should be a liquid, but that's okay. So potassium iodide plus bromine. We said that the bromine will replace the iodine, and so our results are going to be potassium bromide and iodine. Now we got to be careful. Potassium's a +1, bromine's a -1. And so aqueous here, 1 and 1. Iodine is a diatomic, so when iodine's by itself, it should be I2. I think I said it was solid in the grading key. Now this is a little tricky because I want to, when we balance this, right, we need 2 here, 1 here, a 2 here. But be careful. Okay, let's go back to the canvas real quick. I want to make sure you guys understand what I mean on this. We did this reaction. We've written this reaction. This is a proper way to write the reaction. Okay, but on canvas, okay, our options here, oh, they want the iodine first. So the iodine should be first, and then the KBr. And so that means that when I enter my coefficients for the balanced equation, I want to make sure that I swap these two chemicals. And so instead of being 2, 1, 2, 1, it should be 2, 1, 1, 2. Because these should be swapped, because I want to make sure I have it in the same order that it is on the canvas. So it should be 2, 1, 1, 2. So even though I wrote it as 2, 1, 2, 1, the canvas has these two swapped. And so I want to make sure I plug it in as 2, 1, 1, 2 with the coefficients and these chemicals swapped. So be careful on that. I know iodine is solid and 2 KBr is aqueous. Again, it's this idea that this is aqueous, and so anytime you have an ionic compound that's aqueous, it's going to be aqueous. So Lauren's bringing up the simple answer. The simple answer is it's on canvas. That's the simple solution. But if you want to actually understand why, we have an ionic compound. We're starting aqueous over here, which means there's going to be water around, which means if it's dissolved, it's going to dissolve, and so it'll be aqueous. You maybe could argue that this iodine, some of it is going to dissolve, and so putting aqueous here would probably be fine, but you're going to get some of it precipitating as well. So that's why I went ahead and did it as a solid. Don't get stuck about the phases. I'm not going to ever really ask you to predict the phases unless it was like a double replacement. You're trying to find which one was solid. But yeah. India says, Parker, remember the charge of aluminum is plus 3 to iodine is -1, and that 11 is in this equation you're putting these elements together. Yeah, that's a great question, India. Yeah, so the product of that one should be ALI3. ALI3. And then the balancing on that one's a little tricky because it's Al plus I2 makes ALI3. Ends up being like 2, 3, 2 or something. Yeah, no, definitely trying to simplify it for you guys here. Definitely trying to simplify it. Okay. Yeah, 2, 3, 2. So they're talking about problem number 11. All right, I will be available this afternoon. I do have a meeting with the principal and all the other department chairs, which will probably get more clarification on grading and stuff like that. Expect an email from me tomorrow with a calendar for May. Yeah, I was in you. This is due Friday night on Canvas. I'll try to be kind of in my meeting and in Discord at the same time. So I'll be writing out questions. I won't be there for voice until later. But yeah, so I'll be half paying attention to my meeting. Mostly paying attention. It should be short. We'll see. I also have to go into the school again today, later this afternoon. So that's what I'm going to be spending the rest of my afternoon/evening on, is doing more cleanup because they have to do asbestos abatement for some of the countertops. But yeah, no, I am done. Hey, David, we're just wrapping up for honors. AP will be in a half hour. Oh, I got some bits. Valen, those are my first bits, man. Hi, Claire. You want to come say hi? Come here.
Mommy.
You say hi?
Mommy.
Mommy's, I wish she was outside. Why are you sad? Do you want to look? It's you.
Mommy. Reverse.
You want to wear my headphones? Okay, say bye.